As we continue our study of Algebra 2, it's important that you are able to read the basics. What are we talking about in mathematics? How do we communicate that? One of the most basic ideas is this idea of a function, which we use a notation for called function notation. F of x is read as f of x, but it means the value of a function f at the value x. So, if we look at this, something like f of x equals, it's the same idea as y equals. So you may have seen y equals 2x plus 1. If x was equal to 3, you would plug in 3 and you would get y equals 2 times 3 plus 1, which is equal to 7. And so you know the point 3 comma 7 is on this line. What's great about using function notation is now I can say, well, if f of x is 2x plus 1, f of 3 is equal to 2 times 3 plus 1, and f of 3 is equal to 7. I have the exact same information over here as I do over here, but I think this is more efficient. I can see the x and y coordinate in one nice simple equation. F of 3 equals 7. When the x coordinate is 3, the y coordinate is 7 for this function. I think it's obvious, but maybe not to a non-mathematician. We use function notations when graphs are functions. So what makes a function or a relation a function? That's when every x value goes to one and only one y value. Take a look at this example from the textbook that we're using. Again, pretty great example and a lot of information here. So look at part A, f of x equals 2x plus 1. That looks familiar. And there's f of 3 equaling 7. Take a look at f of x equals x squared plus 4x minus 3. You can substitute in 2. Notice everywhere they substitute in 2, they use a parenthesis, collect like terms, simplify, get 9. Plug in 0, get negative 3. Plug in negative 3, you have to be careful. Negative 3 squared is positive 9. Collect like terms. This is my favorite one though. This is the higher level algebra stuff. This has an application that you may not know or understand yet, but trust me that your ability to symbolically manipulate f of x equals this and plug in x plus 1 is hugely important. So notice you plug in x plus 1 in for x and square it, so you have to square that binomial. You have to plug in x plus 1 for x and then distribute the 4, and then you have to collect like terms. Let's take an example, a really complicated example here. It says if f of x is equal to f of x plus h minus f of x divided by h, what would f of 2 plus h look like? Well, that would be f of 2 plus h. Good? So now, everywhere where I see an x in this equation, I need to plug a 2 plus h in. So, I'm going to put this in a different color here, 2 plus h. So here's what it looks like. F of x plus h minus f of x divided by h. Now what am I plugging in for x? I'm plugging in 2 plus h. So I get f of 2 plus 2h minus f of 2 plus h all over h. Now that's all you can do. You can't do anything else. I mean, you could plug this back in for f of x, and you could keep doing that, but it's just going to cycle through over and over again. But this is kind of just working with the symbols and how do things work. We don't know what f is. F is not a number. It doesn't distribute in here. It's a function. So we're just left here. This is all we can do. We just have to leave it there. I'm not a huge fan of this problem because it defines f of x using f of x. So I wish they had done a different notation here, like g of x. But it works. It works. Just it's not my favorite. So that's it. It's working with function notation, excuse me. And when we're working with function notation, all you're doing is taking a value for x, replacing x in that function in parentheses, and simplifying there. All right, have a good night. Peace.